So this is a very small, simple program demonstrating the interface. So we have an interface. What is that interface name? Interface name is language, right? In one key rule for an interface is interface should not have function implementations, right? If you have the implementation, it will give you an error that is abstract method do not specify a body. So this is an abstract method. So what do you mean by abstract? Abstract is nothing but where I do not have a implementation for that particular function. A function will have just a declaration. So what is function declaration? This is how it looks. Return type, everything will be there, but it does not have any body, right? So we end it with a semicolon, right? The next comes is we have some class over here. So what's the class name? Programming language. And this programming language needs to get the particular function that is of interface, right? So this programming language class should use this function. You might say, sir, why do I need to implement an interface? Instead of that, I can give the straight method over here. That's where the challenging part lies. If in case I need to use the concept of multiple inheritance, it is not possible using the extends keyword, right? So interface is used as a backup for the multiple inheritance. So multiple inheritance, how we can achieve? Multiple inheritance means what? Means I get the information from two particular base classes, right? I can access the method and variable from two different base classes. That is called as multiple inheritance. Multi-level inheritance we have already seen before. All right, I think we have cleared on it. So here we have a class, programming language, implements language. So what is this language now? Language is an interface, right? Language is a interface. So language is a interface. Then class programming language implements language. That means this language is what it looks, it understands that language is an interface. Okay. If language is an interface, the first thing is whatever the abstract methods which we have to give the implementation, right? So what exactly is the function name which we have here? Void get name, some parameter here. So get name is a abstract method. So how do you know it is an abstract method? It does not have a body. So one thing is I need to get it. I need to give the implementation for these methods, right? So this is what will happen if I don't have any abstract methods. It will just be a normal method. This method will again not be it will just be a normal method, right? If it is an abstract method, then we have some errors which we'll be looking into. So whenever you inherit a abstract methods, then it is your duty to give the implementation. Got it? So this is one problem which we have. In turn, we can call it as a problem. It is one advantage because whenever if we have more number of methods here, if we have more number of methods, let's assume I have like 6 particular, right? So if we have different methods, it's a duty of whoever is implementing to take care of everything here, to take care of all the methods. Unless until you take care of it, it will not help you or it will not give you, right? So if you can see here, I have a particular error. It is giving it as multiple markers at this line, and we have some 6 different type of marker errors, right? So you can actually go with the error and implement those methods too. right? So we have unimplemented methods. Once, if I give a click, whichever abstract methods is there, for every those abstract methods, I'll be getting a unimplemented method. So if you can see here, 1, 2, 3, 4, 5, including the get name. Whatever the first thing which you had from there till end, everything will be taken care of. Right then, so this is one way of getting it. Now here, our programmer will get to know which are the methods, which are the abstract methods which have not been taken care of. All right. For now, you understand this as what an interface does. All right. You might be having another question, sir. What if, what if I don't want to implement, let's say these two examples. If you don't want to implement these methods in this particular class, you should make this class again as a interface. You should make this class as a interface. All right. So unless until you're dealing with all the functions, it will be a normal class. If you don't want to give any of the implementation for two more, then this will no more be a class. It will become a interface. All right. I hope I've given enough information about it. So what we'll do is we'll just look into what this program is doing and we'll try to understand. All right, so I think this is where the normal program was. So execution of a program will start from main. So yeah, this is a main class, main, and we have an object created, and the object created of whom? The object has been created of programming language. So programming language. Always remember, this is different. This object name is different. Both are different. This is, and also remember that Java is a complete, depending on it's a case sensitive language. But case sensitive means what? That means capital letter and small letter have difference, right? So if I write a particular interface or implementing, right? So you're implementing from this particular interface, that is language. If I cannot use this L, capital L here, right? But still, you have to use it as a the cases, right? So be very careful. And always one tip is a good programmer will always use a capital case letter for the class names or for the interface to just distinguish between, right? To just distinguish between them. All right, so we are creating an object of programming language class. Okay, altogether we created an object for this class. Then I'm creating a memory for, or I'm assigning a memory for it. So now this language dot get name of Java, you're sending a some name as a Java because we're just accepting a string over here on the other side. So Java will be sent to this and the Java will be printed. This is very simple, but still the demonstration of with respect to the interface. So let's run. So once we run, okay, so what do we get? So programming language, that is name, the name is Java, programming language is Java. Right, so very simple and effective program for the demonstration of the interface. And apart from that, all right, so that's it with respect to the interface. Now we'll try to understand what the exception handling is and what does it say. So do we have any doubts here with respect to the interface, guys? All right, we shall move on. Exception handling, very important topic. Most of you might have not used, or yeah, of course, you might have heard about the exception, which will be created from the compiler side or from the execution part. But whenever we get errors at the time of compilation, That means it is called as syntactical error, right? Whenever that means your past regeneration or your respective syntax of that particular program is not according to the mark which we are looking for. If that is the case, then we call it as a syntactical or syntax error, right? So syntax error. These are the errors which we get it. Like I'll show you here if I have made any mistake by not giving any value. So something is happening, right? You have given it as a name, but you are asking me to print for NAE. NAE is not declared, right? So it is giving me that NAE cannot be resolved to a variable because I have not given any information about NAE, right? So this is called as a syntax error, right? Or if I don't give a semicolon here, so it gives an error. What does it say? You have not terminated properly. Probably there is a semicolon at the end of that particular statement. It is suggesting me, right? So compilers nowadays have been trained in such a way that it, it, it will be looking for a particular format, proper way of representation, and if you're not giving it, it will easily get to know that, okay, in other words, it is pinpointing you where exactly the error is. Is it not? Of course, it's not only with Eclipse, we have many other IDE which takes care of autocorrecting it sometimes, or suggestion which it gives, right, or the answers, right, or the help. We also have a help here, right? If you have any issues, we can always get the help from this IDE too, right? Right. So whenever you have a syntactical error or a compilation error is called as a syntax error. Whenever you get some errors at the time of execution, it means the program is running, and then it is under the execution. So there something happened. Then an exception will be raised. Then the exception will be raised, and Java needs to handle that exception. All right. Before Java needs to handle that exception, it is the programmer who needs to handle the exception. How exactly a programmer can handle the exception? The first thing is the function should take care of the exception. If the exception is not handled by that particular piece of code or the function where exception was raised, it will be pushed to the main method. The main method will again need to deal with that error. If the main method is not able to deal with that error, it will be throwing towards the Java, the JRM, right? So there, even the exceptions are not handled, your complete application will hang. Your application will hang. It doesn't know what to do. The Whenever this situation happens, most commonly we can deal with the syntax errors 100% nearly, right? But when it comes to the exception, there's always probably that they can hang up, they can be somewhere locked into because of some resources which is not available at the time, or the memory issues, or your accessing issues, then your requesting issues, then the hardware may not be actually working towards it. Right? Many sort of issues may arise in the execution time. Right? That is in the runtime part. So this is not in the hands of a programmer actually. Right? Exceptions are not exactly in the hands of a programmer because those are unexpected errors. Right? So if I have a 10 GB of memory, if I have a 10 GB of memory and because of some problem, memory was collected so much and the garbage collection didn't happen, the memory got filled. 10 GB of memory which was allocated is completely filled. Then what to do? Because of some error with the garbage collection or improper utilization of a memory got filled. You're getting it, right? So once it happens, it is looking for some memory which is not present in the exception. There comes the error. There comes the error. Then we need to deal with it, right? So that's about the exception which we'll be looking into it. So today, all right. So what is an exception? As a definition, an exception is an abnormal condition that rises in a code sequence at runtime. Runtime is important. All right. In other words, an exception is a runtime error, as simple as that. Right? Definition holds very simple for an exception handling. So, all right. Typically, through the use of error codes and so on, this approach is a cumbersome as it is troublesome. It looks very simple, but it is very difficult to identify. Right? I can say that okay, in the piece of code of 1,000 lines of code, as a good programmer, he'll be able to identify, all right, where exactly the exception happened. If it is having a million lines of code, how do we deal with it? Getting? So in Java, exception handling avoids this problem and in process brings the runtime error management into the object-oriented world. Right? We'll try to explore much and more of this. Right? So when we speak about the fundamentals here, when we speak about the exception handling fundamentals, so there are new keywords which we see. For example, we see a try block. We call it as a block from here now. We have a catch block, we have a throw block, we have a throws block, and we have a finally block. All right. So exception handling itself has been handled by 5 keywords, that is try, catch, throw, throws, and finally. We'll try to understand what each block actually say. What do we mean by a try block? What do we mean by a catch block? How do we deal with the throw? What does the throws do? And ultimately, what is this finally used? Can we have this finally compulsorily, or should we have this try block compulsorily? Should we have this catch throws completely throughout the program? We'll try to understand this about the exception handling fundamentals. All right. So what do we mean by a try block? What do we mean by a try block? So try block in the sense it will be looking in this way. So we have some methods. Let's call it as some void ask value. So let's assume that there is a method which is called as a ask value method, and this ask value is having some lines of code which is susceptible, or probably they may raise an exception. Right? Chances are nearly zero, but there are chances that a runtime error might come out from that particular place. Identify those set of statements. Those statements should be within this try block. Within this try block. If you are not putting any of those error generating statements in the try block, you cannot handle those particular exceptions. As simple as that. So what does it say? Program statements that you want to monitor for exceptions are contained within the try block. If the exception occurs within this try block, it is thrown. Okay, now we have another use of thrown, but we'll come back to that thrown. Whenever you have any error, whenever you have any issues with those, as I said, susceptible or monitored codes, those should have to be under the try block. But where an exception handled, whenever the exception is raised, and that exception has to be caught by someone, right? So in other words, caught by someone refers to there is a catch. There is a catch block. So your code can catch this exception. Try block, throw some through some exception, right? So this throwing needs to be caught by someone. Who needs to caught it? I mean, who needs to catch it? This catch block will catch the particular exception. And what does this catch block do? This catch block will handle that exception. Right? How do we handle that exception? Okay, it identifies, okay, what sort of errors are these? Right? We have hundreds of exceptions which are actually available, right? And there are always the chances that a new exception might occur later on. Right? It all depends upon what type of error we might encounter. All right. So if an exception occurs, it has been those exception cases or statements should be in a try block. And whenever an error arises, the try block will throw the exception. Who needs to catch it? You need to catch it in the function, right? So how do we catch it? You just mention a catch block, and we have a proper exception handlers, right? So we have to handle those exceptions whichever has been thrown, and there are also some priority, right? There are also some priority in the exceptions too. We'll try to understand, right? If in case you're not handling, that means you're not given the catch method, then the system will handle the exceptions which are generated. There are some issues. If the system is not able to handle those errors, your application will just hang. You see in your cell phones, few of the application will hang. Have you anywhere wondered what exactly it is doing? Right? Usually, uh, whenever you're sending a normal message or you're sharing some document, your application just goes to a halt. It just sits there doing nothing. Why? Exception was raised. It was not able to deal with it. A small example in the older phones is whenever you're copying some memory from one place to another, and unfortunately, the copying stopped. Why? Copying stopped because of some memory issue. Right? This memory issue was not there at the time of sending. At the time it knew that, okay, it checked, okay, I have this many memory and this data can fit into it, it sent it. But later on what happened? Later on, because of some XYZ, memory was not available. And unfortunately, the copying has stopped. This unfortunately copying has stopped needs to be shown for the user too. If it is not shown to the user, what's the use? Is it not? So it has to be shown to the user. If you're not showing these related values, that means you are poorly handling your application. Right? Your user should know why exactly it stopped because of some memory issue or some data which cannot be transferred or illegal information or not a quite compatible data. Right? You need to be helping the user to know it. All right. So any exception which has been caught, right? Which has been caught, that is, you're using it, right? So fine. If you're catching in that particular same method, no issue. If you're not handling in the same, if you're not handling with the, no, if you are not handling within the same particular block, then the chances are you can send it or you can throw it again. You can send the exception to someone else. So how do I do it? I use a keyword called as throw. I use a keyword called as throw. This throw block tells us that you're not handling that particular exception in this particular method, right? Any such exception that is thrown out of the method must be specified in the throws clause. That means this method should tell that I'm not handling the particular exception over in my particular method. I'm throwing. That means you have to specify here that in the method itself that I'm not handling my exception. Any code that absolutely must be executed after the try block completes is put in a finally block. Ultimately, we came to the last keyword, that is finally. So what is the use of finally? Finally will be executed regardless of there is an exception. So what exactly happens when an exception arises? Your system will straight away halt at that particular point. If you are opening a database, you are getting the information. Unfortunately, exception raised and your machine halted. Halting means that database which you have opened, right? is not closed properly. If you're not closing it properly, anybody can get into it, or it may not be accessible to someone else. Two choices, right? So regardless of whether you're using the data or whenever the exception happens, or at the time of your exception, you didn't close that particular database, I need to run few information even when the exception handling happens, whenever the exception has been raised, right? So even the exception are raised, even the system will come to a halt. I need to take care of the database. I need to take care of memory locations, right? So I need to complete the process of opening the database, getting whatever I need, closing the database. This closing related information, or the which we call it as a connection, closed connection, right? Whenever we are closing the connection, those related information will be put into the finally block, regardless of exception happening or not. This finally block will be executed. Any information of database closing should be put up in the finally block. All right, so this is how a try block looks like, the general form. Try with the codes which are monitored. That means we may have some related codes which will generate an error. So how does the catch block have? Catch block will be with the name of exception and its object. If you narrow it down, we have 100 plus exceptions. If you exactly know what might happen, you can handle that particular exception type alone, right? So this is for the exception type 1. So this can be with exception type 2. Finally, you can go for, if there are any types of exception, you can go there, right? So this is how the finally block look like. Block of code to be executed after try block ends. All right, so exception type, we have many types of exception types, right? So we'll be just think, I'll be just showing how many types of exception types are there. Exception types in Java, right? So we have two types of exceptions: checked exceptions and unchecked exceptions. So these are the one. So exceptions can be categorized into two types: checked exception and unchecked exception. So what do you mean by checked exceptions? Checked exceptions are basically class not found exception, interrupted exception, IO exception, instantiation exception, SQL exception, file not found exceptions. We have hundreds, right? We also have unchecked exceptions. Array exception, class, null pointer, null index, array store, illegal thread state. It goes on. It goes on, right? Uh, so those are with respect to the type of exceptions. So more information has been given in the javapoint.com, right? Very simple and straightforward website speaking about the Java here. And coming back, yeah, we'll be dealing with respect to the exception that has to be caught, exception or uncaught exception with respect to few of the example programs related to exception handling. We'll try to see in the next class. All right, thank you, class.